Hey there, ladies and gentlemen. I forgot that you were coming over here to talk to me. So let's just kind of get this going. I got my 3D printer making some stuff for me. Hopefully it doesn't distract us too much. We're talking today about different transformations and how they change the way our graphs look due to what is happening in the equation. So we have transformations is our big key idea here. And we should know what transformations are. We did this kind of stuff last year and years before. You'll hear words like reflection, translation, and all that kind of cute stuff today. So here's a translation. It's when we slide something left, right, up, or down. And we're going to talk about just things going up or down with our current information that you see on the screen now. So our parent graph is this black line parabola. It is the f of x is x to the second power. If we add a 6 to that parent graph, it shifts this entire graph up 6 spots. If we subtract a 7 from the parent graph, it shifts the entire graph down 7 spots. So just like you would think at the end of it, if it says plus 6, that goes up 6. If it says minus 7, it goes down 7. So you're just going to look at those things to determine if it goes up or down. So our job right now is to explain that the graph shifts up or down compared to the parent graph. So in letter A, we have a plus 10 at the end here, and the order of it doesn't really matter. You could rewrite this in more of a standard form of an x squared plus 10, and we know that it's going to shift. The vertex is going to shift. Let's use the words here. Vertex shifts up 10. On part B, the vertex is going to shift down 8. So that's all we got to be able to do is explain those words. It's going to shift down 8. And that's as easy as this lesson is going to be for this type of a problem. Now, I'm going to ask for you guys just to give me the answer to this question. This would be kind of a way I can check to see that you're actually watching the video. So you're going to give me tomorrow, when you come back to class, we're going to ask you, is it an A, a B, a C, or a D for your correct chance to say this, and we're just going to have you guys write that on your desks. All right, dilations. Dilations are our next thing that we're going to talk about. A dilation is when the graph goes more narrow or more wide. Now the way that things happen is, if you'll notice carefully here, is that our coefficient is going to tell us if things are going to get narrower or wider. So if the number of our A is less than 1, so like a fraction or a decimal less than 1, our graph is going to get wider. If you imagine like taking a rubber band and stretching it wider. So it's going to be more of a wider graph. If our graph is a multiplier that is greater than 1 in front, like this 3 is, it's like stretching a rubber band more vertically to make a more narrow graph. So a number less than 1 makes it wider. A number greater than 1 makes it more narrow for our parabola. And that's what we need to be able to then describe using those types of words. We also have reflections. A reflection is what we already talked about in 9.1, where you just flip it over a line. So we have, if the A is positive, it just opens upward. If the A is negative, it opens downward. And we've already talked about that stuff. So this one's not a new one for us. The last thing that we need to talk about is horizontal translations. For our graph to shift from being where it is right now to the right or shifting to the left. So it's exactly what you would think, except for we have it in the parentheses. So the H value tells us if we're going to shift right or left and by how many spots. So a negative H, or this number right here, if H is greater than 0, it shifts to the right. If it is less than 0, it shifts to the left. So what our job now is to use all that information and describe all of the different transformations taking place to this one, a negative 3x squared plus 1. So what we would say is that we are shifting the vertex up 1 because of the plus 1, and we would also say that it is becoming stretched vertically. Okay, so we have a narrower graph, narrower by 3, and then we have it flipped over the x-axis because it's a negative 3. So that negative tells us that we're going to flip it over. So those are the 3 things that we're describing, and that's just us being able to name these things based off of how it looks. So if you were to graph these things, you would then see all of those different things taking place based off of how it would normally look as a parent function. All right, we're going to ask you to do one of them on your own. I want you to describe for me what is happening for my 1/2 x to the second minus 4 as it's related to the x to the second. You're just going to write down what you believe it is. We'll talk about it when you come to class. Please use words like compressed or stretched. So compressed makes it wider. Stretched makes it more vertically stretched. So narrower and wider. All right, folks, that's all I got for you. This is how lesson 9.3 works. Hopefully you're finding this stuff to be extraordinarily easy. If you're not, check with your friend, check with your mom, check with your dad, check with your parents, check with whoever you need to check with your teacher, and we'll be able to get these things figured out. All right, this is the Berman Nation. We are signing off.